As we transition into an age of growing populations, dwindling natural resources, rising space programs, and normalizing of digital applications, there's a need for structural innovation. Whether you are a civil engineering major designing bridges, a business major working downtown in a skyscraper, or even an education major going into a school building, there's a mutual need for architecture in your place of work. It is generally known that concrete is the most widely used material in today's society. You can see this by walking down the sidewalk, pulling up into your driveway, or even walking into a concrete building. So, this need for structural innovation directly correlates to the dire need for concrete innovation. Today, I have brought forth what Colorado Boulder biologist Will Shubar names living concrete. Throughout this speech, I will inform on the science behind this living concrete, the testing and current applications of the living concrete, and the future applications and ideas scientists have proposed this concrete can be used for to shape the future generations. March 16, 2017, Colorado Boulder's scientist Will Shubar was given a grant of $2 million to research deeply into living architecture. According to Shubar and the Living Materials Laboratory's website, this living concrete is a development of bacteria, polymers, gelatin, and much more to try and create a hybrid between architectural and biological functions. As the New York Times puts it, this bacteria is photosynthetic in nature, meaning it can take in sunlight and can even take in carbon emissions to grow this living material structure. So what is the big deal with this living concrete? Teresa McAmer of the Smithsonian goes on to discuss that the regenerative testing of this concrete can create 8 children concretes from 1 adult. So as we see this black square cube, there's 1 concrete block, which was therefore in turn created into a second. So according to the McAmer, there will become 8 cement blocks from this single left cube. Now, if we go down into a diagram put out by Colorado Boulder, we have the action of cyanobacteria filling in cracks. On the left and the right, you have cyanobacteria, and in the middle, there's a designed black line to signify the crack. This regeneration shows that if you, with proper care and water, the cyanobacteria will mate in between the lines and fill in the crack. Now, this is monumental for a multitude of reasons. What is previously deemed as uninhabitable conditions for cyanobacteria, concrete, you can now put cyanobacteria, which will take in bad emissions from growing populations and more use in cars. Also, now you can transport the same amount of concrete in smaller payloads. This means that if you cross a desert or tundra, you can take less trips and therefore make the same building. Also, it will self-heal from disasters, as seen in that diagram. Lightning, hurricanes, or even tornadoes can be recovered from this living cement. And if we look further into the slide, we have a graph of the cement creation and emissions and the big contrast in cyanobacteria. At the bottom, we see that about 4,000 millions of tons of cement is produced in China. Now, if we look at the cyanobacteria, that green signifies that photosynthesis is taking place and carbon is being intaked, which is very good for the climate. As stated in the intro, the inevitable growing populations and space exploration yields for a need for structural innovation. Living concrete, I believe, is that innovation. Avery Thompson of Teslarati.com goes on to quote Will Shubar, says that this concrete can allow for efficient travel, synthetic biological signals to toxic chemicals, and even light up possibilities to signify structural breaks or structural problems. Overall, adding a living aspect to structure will have limitless possibilities. For instance, if we look at the slide, you have Falcon Heavy, a SpaceX rocket. With the integration of SpaceX into NASA, this will probably be one of the most common used spaceships or rockets to date. The payload capacity of Falcon Heavy to Mars is about 17,000 kilograms. So this would be about 250 cubic feet normally. With the living bacteria, we can bring about 2,000 cubic feet of living concrete to Mars. If we look to the right, the coloration of the cyanobacteria inside the concrete is shown. This will change due to toxic waste in the air, which is normally unseen, such as carbon monoxide, or can even integrate light up to signify the structural damage. Today, I came to inform everybody on the innovative idea of living concrete and its limitless possibilities. From the technical applications of the living cement used, such as reproducing concrete, traveling lightly, and even fixing cracks, to the futuristic ideas such as incorporating updates of support via colors, this living concrete is a tangible item that will move our world forward. As students of Purdue University, I hope that we can look at this information, research more deeply into it, and therefore push humanity forward even further with such a unique development. Thank you.